Welcome. We're going to start this lesson with a warm-up problem. Pause me and try to solve this quadratic equation. Were you able to solve it? Did you try the square root method? Yeah, that's not going to work because our variable is both being squared and being raised to the first power. So square root method is not going to work. Did you try to factor it and use the ZPP? Yeah, that's not going to work either because the quadratic x squared minus 4x minus 6 cannot be factored. Bummer. Okay, so far the two techniques you've learned to solve quadratic equations only work for some quadratic equations. And this is one where it doesn't. So in this lesson, you're going to learn a strategy that can be used to solve any quadratic equation, and it's called completing the square. So where did the name for this technique come from? And I'm just going to walk through a little simple example. I'm going to start with a binomial being squared, and we're going to draw a little area model to do the squaring. It's a square, so we have x plus 2 on one side, x plus 2 on the other, and we get x squared, 2x, another 2x, and then a 4. It's this number right here that completes the square. And that's where the name came from. So if I wanted to multiply out the binomial x plus 2 squared, it's equal to x squared plus, notice we have two of these, 4x plus 4. Let's try some examples to try to find the number that completes the square. If I have x squared plus 6x, what would I need to add to complete the square? I'm going to draw a little area model. And I know I'm going to have x squared here. I'm going to take the 6x and split it in half. 3x goes here and 3x goes there. So I would have x plus 3 on one side of my square, x plus 3 on the other side. And I know that 9 completes the square. The nice thing about this, x squared plus 6x plus 9, I can now factor this, and I know I factor it into a binomial that's being squared, x plus 3 squared. All right, let's try another one. I have x squared plus 16x. What would I need to add to complete the square? And again, I think the area model gives us a great visual. We have x squared. I need to take the 16x and split it in half, an 8x there and an 8x there. So I know my sides of my square, 8 plus x plus 8, x plus 8. And what completes the square? 64, 8 times 8. And the nice thing is now I have this trinomial, and in fact it's called a perfect square trinomial because it factors into x plus 8 times x plus 8, or x plus 8 squared. All right, I'd like you to pause for a minute and think about at least two patterns that you're noticing is happening when we complete the square. All right, I hope you found some patterns here. A couple I noticed. If I take this middle term and specifically look at b, so b is equal to 6. If I take 6 and divide it by 2, that's equal to 3. 3, 3, 3, 3, 3. Let's see if that holds true over here for 16. 16 divided by 2 is 8. Notice 8, 8, 8, 8, and 8. All right, another pattern I notice is if I take this 3 and square it, I get the 9, the number that completes the square. If I take this 8 and square it, I get 64, the number that completes the square. All right, now that we've seen a few patterns, I would like you to pause me and try those first two examples and then try to generalize it. Okay, so pause me, try those, and then come back. All right, welcome back. Let's quickly do the first one. I know b is equal to -8. If I take -8 and split it in half, I get -4. And then if I take -4 and square it, I get 16. So 16 completes the square, and it factors into x plus -4 or x minus 4 squared. And let's look at the second one. B is equal to 5. So my first task is to take 5 and divide it by half. I'm just going to keep that as a fraction, 5 halves. And then I'm going to square 5 halves, which will give me 25 fourths. So 25 fourths completes the square, and it factors into x plus 5 halves squared. So see how we're using both the 5 halves and the 5 halves squared. Finally, if we're going to generalize, mathematicians love to generalize, I take b and divide it by 2, take just half of it, and then square it. This is going to give me what I need to complete the square, which is b squared over 2 squared, or 4. So b squared over 4 completes the square, and it factors into the binomial x plus b divided by 2 squared. All right, you've reached the intermission of this lesson. There's a lot. I know there's a lot already in your brain. So take a break, breathe, drink some water, maybe move and stretch, review your notes. Did everything make sense that we've done so far? Because we're going to be building off of that. Whenever you feel ready, come on back and join me. All right, welcome back. So at this point in the lesson, I really hope you're thinking, what in the world does completing the square have to do with solving quadratic equations? All right, let's return to our original equation that we couldn't factor at the beginning of the lesson. Remember, we tried to factor it and use the ZPP, didn't work, and there's no way we can take a quadratic that can't be factored and factor it. So this means that we're going to need to get creative with the square root method. We're going to need to somehow use the square root method to solve this quadratic equation. Now we can only do that is if we can take x squared minus 4x, our terms with the variable, and somehow convert them into something like x plus something squared into a binomial squared. Because if we can convert x squared minus 4x into a binomial squared, we can use the square root method. And this is exactly where completing the square comes into play. So if I take x squared minus 4x, what would I need to add to complete the square? Let's see, I take b, -4, I'm going to divide that by 2, and that gives me -2, and then I'll take -2 and square it for +4. So that means if I add +4 here, I'm going to be able to factor this trinomial into x minus 2 squared, because -4 divided by 2 is -2. Awesome. Now remember, with equations, whatever we do to one side of the equation, we better do the exact same thing to the other. So I'm going to also add 4 to the other side of the equation. So we're left now with x minus 2 squared is equal to 10. Now this should make you so super happy, because now we have this equation in a form where we can use the square root method. We know how to do that. We're going to take the square root of both sides and make sure we get both the positive and the negative square root of 10. And then to isolate x, I'm going to add 2 to both sides. So I'm going to have 2 plus or minus the square root of 10. So this equation has two solutions. I can either start at 2 and subtract the square root of 10, or I can start at 2 and add the square root of 10. Now, if we wanted to do a quick estimate, I know the square root of 10 is something a little bit more than 3. So I'm going to say that's about 3. So x is about -1 and about 5, if we just wanted to think where those numbers were on the number line. All right, we're near the end. We're going to end this lesson with 2 examples. So please pause me and try both yourself and then come back and we'll solve them together. Welcome back. I hope you made a little bit of progress solving both of them, and don't be surprised if you got stuck along the way because there are a few little nuances about both these problems. All right, I'm going to start with the first one, and to complete the square, I need to take the constant and sort of put it on the other side of the equation. I'm going to add 35 to both sides to get x squared minus 2x equals 35. And I did that because I want to isolate both of my variable terms together on one side of the equation. Now, because of this, I can complete the square. So I'm going to have to add something to this side to make it a perfect square trinomial. And whatever I add to one side of the equation, I better do the same thing to the other. So I'm just going to kind of get set up for that. All right, let's see. To complete the square, I need to take my b, -2, divide that by 2 to give me -1. Then I'm going to take my -1 and square it to give me +1. So +1 is the number that completes the square. And I'm going to add it to both sides of the equation. Now I know x squared minus 2x plus 1, that's a perfect square trinomial. I know it factors into the binomial squared x plus a -1, or x minus 1 squared is equal to 36. All right, all the hard work is done. We're back to something we know how to solve using the square root method. I'm going to take the square root of both sides. It's going to give me plus or minus the square root of 36. So x minus 1 is equal to plus or minus 6. And x is equal to 1 plus or minus 6. That means x can be 1 minus 6, or -5, or it can be 1 plus 6, 7. So this quadratic equation has two solutions, -5 and 7. Those are the values that make the equation true. All right, let's look at the second example. Hopefully you said, yikes. What do I do when a is not equal to 1? So hopefully that caused you a little bit of thinking and maybe a little bit of concern. All right, so this is a really important point. To complete the square, a must be 1. So I'm just going to take whatever a is and divide both sides of the equation by that. So 4x squared plus 24x plus 28. I'm going to divide that entire side by 4, and I'll also take the other side and divide it by 4. I'm going to distribute division to all three terms and get x squared plus 6x plus 7. 0 divided by 4 is simply 0. All right, this is so important because now a is equal to 1, and I can complete the square. Don't be surprised. There are times when you're going to have to divide by a, and you're not going to get integers for b and c. You're going to get fractions. Totally fine. Okay, so to complete the square, I need to isolate both of my variable terms on one side of the equation. So I'm going to subtract 7 from both sides. -7. I'm going to get ready to complete the square because I know I'm going to have to add a number to complete the square. Whatever I add to one side, I'm going to add to the other. This little step of adding these blank lines will help you remember to do the same to both sides of the equation. All right, I'm going to take my b, divide it by 2. It's going to give me 3. And then I know if I take 3 and square it, that's my number to complete the square. So 9 completes the square. And then x squared plus 6x plus 9 is going to factor into the binomial x plus 3 squared. -7 plus 9 is +2. Great, I'm now at a point, I know how to do this. I'm just going to use the square root method. I'm going to take the square root of both sides, which can be plus or minus the square root of 2. To get x all by itself, I'll subtract 3 from both sides, -3 plus or minus the square root of 2. So my two solutions, the two values that make this equation true, -3 minus the square root of 2. Square root of 2 is about 1.4, and -3 plus the square root of 2. All right, so this lesson was a lot, but this idea of solving quadratic equations by completing square, and in fact, even this technique of by completing the square is such a big idea for algebra. So don't be surprised. It's going to take practice to get comfortable with this. And you may even want to come back and selectively watch parts of this video again, or just ask me questions, ask me during class or ask me during office hours. So keep working on this, you're going to get it. Um, and it's a really cool technique.